On question number 6, it's backwards. Pretty much the same thing we did on question number 5. List all the ways to prove that a quadrilateral is a parallelogram. One pair of opposite sides congruent and parallel. Yes. That's the one that's different than just given the parallelogram. Both pairs of opposite angles are congruent. Makes it a parallelogram. The diagonals bisect each other. Makes it a parallelogram. That's what we did in question 5. One pair of adjacent sides, and nope. The diagonals are perpendicular. Nope. Now in question 7, there's more than one choice, but it looks like based on everybody's answers, everybody did it the same way. So I want to make this a parallelogram. Well, notice from my point here, it's horizontal, and if I count here, it goes over 1, 2, 3. So what I'm going to do in the bottom, I'm going to go over 1, 2, 3. This point makes it a parallelogram. So I'm at the point 1 and -1. Just to show you, you didn't have to do it that way. We could have connected them like this. And then I would have had a point over here, wouldn't I have? Now on question 8, I've got this quadrilateral, and P is at 0 and 2. Q is at 0 and 6. R is at 6 and 0. I know I wrote R on this one. I didn't write it on the others. And then I've got another point at 2 and 0. Well, the way that it looks here, that's not a parallelogram, is it? We can see these two sides are parallel. But then I got a vertical side and a horizontal side. That's not a parallelogram. You don't have to graph it, but it makes it a lot easier. If you don't graph it, then you either have to show me the slopes or the distance. Okay, now on question number 9, we know ABCD is a rectangle. Since it's a rectangle, we know that the diagonals are equal, and we know that the angles are 90 degrees. I already marked the 90-degree angles for you. So I know A to C is 3x minus 11, and B to E is 3x plus 5. Well, I really want to compare my diagonals. So B to D, I want to find that B to D, that'll be 2x plus 10, won't it? Because that is double it. Because this is x plus 5, and that's x plus 5. Since I know A to C is 3x minus 11, I know 2x plus 10 equals 3x minus 11. Well, let's just do the algebra there. Subtract 2x from both sides, we get x, not 2x. 3x minus 2 is x. Add 11 to both sides, x is 21. Now I want to find B to D. So I take 2 times 21 plus 10. That will be 52. And there's your answer.